Hi, welcome to my video on sinusoidal word problems, part 2, finding the period of a sinusoidal function. Find the period of each sinusoidal function. Number 1, we have theta from 40 to 160 marked on the scale here, and we have a maximum and a minimum point. So the period is the number of degrees. So if this is 40 to 160. So 160 subtract 40 gives 120 degrees. So from here to here is 120. So we take the 120 and divide it by 1, 2, 3. You get each degree here 40. So 40 plus 40 is 80. And 80 plus 40 is 120. So the period is from 40, from max to min. The period is right here, half the period is from 40 to 120. So 120 subtract 40, that's half the period. So half the period is 80. So the full period multiplied by 2, you get 160 degrees. From max to min, it's only half the cycle because now it's got to go back like this and back up again. So that's 80 down from here to here. Then it's 80 from here to here. Number 2, again, we got a min to a max this time, or a max to min. It's this here it's going down and then up. Here it's going up. And again, just to remind, the other part of this would be going on like this on over here. So we go from, this is in radians, so this is pi over 6 up to 2 pi over 3. So that's half the period is 2 pi over 3 minus pi over 6. So half the period is, common denominator 6. So 3 into 6 goes 2. 2 times 2 pi is 4 pi minus 6 pi. So half the period is 4 pi minus pi is 3 pi over 6. So half the period is pi over 2. And you double it. P is 2 times pi over 2. Just to show you, the 2's cancel, so the period becomes pi. Again, from min to max is only half the period. Now, number 3, this time we have a height and we have a time in seconds. Here we had y and theta. Now we have max to min again is only half, because if you think about it, the other half is going up like this. Just trying to. So the period, that's 15 to 3. So the time in seconds, 15 minus 3 is 12. And we got 1, 2, 3, 4. So 12 divided by 4 gives you time. Again, not because it's 3 here, but the intervals here are equal. So that's a 6, 9, 12, 15. So the time interval, half the period, is 3 to a 9. Going from max to min, you go from 3 seconds to 9 seconds. And so half the period is 6. So we double it. P is 12. So the period is 12. And we'll do S for seconds, 12 seconds. Notice the period here is in terms of degrees. The period here is in terms of radians. But this is could be a word problem, and the period is in terms of time. Number 4, again, we have a min to a max. And this time, the time starts at 2 and ends at 10. So the period is 10 minus 2, which is 8. But that's half the period from 2 to 10, which is 8. And now the other half is when you come down like this and go over. So that's half the period. So half the period is 8. So the full period is 16. And again, S is for seconds. And I'll just write SEC because my S's look like 5. So that's 16 seconds. Okay, let's continue. Number 5. The maximum value to the minimum value is 120 degrees. Remember, the max to the min is 120 degrees. So that means that half the period is 120. So double it, the full period is 240 degrees because it has to go up again. So that's also 120 to go from here. And it makes no difference from 0 to 120 or from it could be anything at all. But it's 120 degrees here. It's 120 here. So it could be from 10 to 130, and then it could be from 130 to 250. So we don't know where it starts at, but we know it's 240. Min to max is doing this. Min to max is half the period. Again, the other half is here. So this is 2.3. And this is 2.3, so half the period is 2.3 seconds, so the full period is 4.6 seconds. Again, 2.3 plus 2.3. Now, this one I made up a little bit different. Number 7, the maximum value to the sinusoidal axis is 0.9 seconds. So let's just draw a little graph here. Let's pretend this is the sinusoidal axis. This is the axis of symmetry or sinusoidal. Say the sine axis, instead of spinal sinusoidal. Sinusoidal axis is here. From the max down to the sinusoidal, right here, it's 0.9. So if you think about it, this has to go on down to the min, and then it has to come up again to the sinusoidal and go up to the top. Because if it from max down, it has to do all the way down from max to min and the min to max. So that's 0.9 here. This is 0.9 here. And from here to here is 0.9. And then from here to go to the top is 0.9. So that's 1/4 of the period is 0.9. Again, 1/4, half, 3/4, full. So there's 4 parts. So multiply by 4, you get 3.6 seconds. So maximum to sinusoidal is only 1/4 of the cycle, 1/4 of the period. Number 8, I made up 2 little different problems here in terms of the period. An object moves at a rate of 8 feet per second in a straight line. The maximum distance is 50. The minimum distance is, and I forgot to put in, when I read it, I forgot to put in the 26. The maximum distance is 50, the minimum distance is 26, and minimum distance of 26 feet is recorded, and it says find the period. Well, excuse me, the maximum distance minus the minimum distance is 50 minus 26. So that distance is 24 feet. But we know that distance equals rate times time. So if I want the period, that means the distance divided by, and I'll say R. I'll say rate, even though I got an R here. I'm going to put rate here so I won't get confused with the radius of a circle when I do a wheel turning or a fierce wheel turning. So the R here stands for rate, so I'll put the rate in. So that means the distance traveled is 24 feet, and it's traveling at a rate of 8 feet per second. And so what's the time? So 8 into 24 goes 3. So the time is 3. And let me work this out. So I have feet divided by feet per second. So that's feet multiplied by seconds over feet. So the feet cancels and I get seconds. I just wanted to show you. It's easy to see 24 divided by 8 is 3, but I wanted to show you this working. This is like a numerator and the denominator. You multiply by the reciprocal. The feet cancels out and you get 3 seconds. And the last one here. A wheel has a radius of 25 centimeters and it rotates at a rate of 5 pi centimeters a second. And we want to find a period. So the period is, we have a radius, and I'll call the radius R. Radius is 25 centimeters. And the rate, I'm going to call the rate instead of R, I'm going to call it RAT. The rate is 5 pi centimeters per second. So the how do you find the time? Well, we know that in terms of time, we have time is the distance divided by the rate. But the distance, this is a wheel turning, so the distance is the circumference. So the circumference is 2 pi times the radius. So the circumference is 2 pi and the radius is 25 centimeters. So the circumference is 50 pi centimeters. So if you want the time, go back to here. The distance is the c. So we can put 50 pi centimeters in for the distance because that's the circumference, divided by the rate, which is 5 pi centimeters per second. And 5 into 50 goes 10. And again, pi's cancel out. 5 into 50 goes 10. The pi's cancel. And this converts to seconds again. Centimeters divided by centimeters per second is centimeters times seconds divided by centimeters. Centimeters cancel and I get seconds. So the time is 10 seconds. I thought I might mention due to two of these problems because they're involved in the word problems that we're going to do on finding the sinusoidal equation of the wheels turning or dolphins swimming, which is sinusoidal function. So that's a few problems to introduce you to finding the period, because we're going to need to know that when we do the word problems. And that brings us to the end. And if you like my video, click the like button, click the subscribe button if you wish. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.